Trigonometric functions of acute angles. Special right triangles. Hopefully this is something you also recall from geometry. We're going to work with 30, 60, 90 triangles and 45, 45, 90 triangles. These are both widely used in real-world application, and they have some given properties that we can just always have memorized. So first of all, with our 30, 60, 90 triangle, we can look at the side lengths proportional to each other. So across from our 30 angle is always going to be 1 unit. Then across from our 60-degree angle is always going to be square root 3. And across from the right angle will be 2. Likewise, with our 45, 45, 90 triangle, we've got 1s across from our 45-degree angles, and then square root 2 across from our right angle. This is a figure that you're going to want to have in front of you whenever we do most problems in this concept, including whenever you're working on your homework. We're going to fill out the following trig functions for parts of these triangles. The first thing I'd like you to do is to label your triangles as 30, 60, 90 and 45, 45, 90. Next, we're going to write down the proportions of the sides to help us out as well. So across from our 30 is always 1. Across from the 60 is going to be square root 3. And across from the 90 is just going to be 2. Across from both of our 45s is 1. And then across from the right angle is square root 2. Now you need to label each side as. Now I want you to notice that our reference angles that we use in these 6 examples changes. So we've got 60, 30, 30, 45, 60. So depending on which reference angle we have, that will determine what our opposite and adjacent values are. So starting with number 1, we're using 60 as our reference angle. That means that square root of 3 is my opposite and 2 is my hypotenuse, which are the 2 values that we need for sine. So sine of 60 is equal to square root. So sine of 60 is equal to square root 3 over 2. Next, we have tangent of 30. 1 would be our opposite side, and square root 3 would be our adjacent. So tangent of 30 is 1 over square root of 3. But we can't leave our answer this way because it's not proper. We need to rationalize it. So we're going to multiply the top and the bottom by square root of 3. And we get square root 3 over 3. Okay, I'd like you to pause your video and do problem 3, restart it, and see what my answer is. Since cosine is adjacent over hypotenuse, you should get square root 3 over 2. Now we're moving on to cosecant of 45. In our 45, 45, 90 triangle, we have 2 angles that are 45 degrees. It doesn't matter which one you pick as your reference angle. So cosecant is just the reciprocal of sine, which is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So we're going to have square root of 2 over 1, which is just the square root of 2. Okay, pause your video and I want you to do problems 5 and 6 and then restart to see my answers. Here's a quick reference table for you. We found some of these in the example above. You could find the rest of them on your own, but these are all common functions of 30, 60, and 45 degrees that it might be nice to have in a table. Solving special right triangles. Set up a proportion with each triangle and their similar special right triangle, and then solve for each unknown. So the first thing I want to do is I'm going to draw a 30, 60, 90 triangle that's oriented the same way and put those proportional sides on it. So again, I proportioned this so that my 60s were in the same place and my 30s. Okay, so let's start with solving for B. We're going to set up a proportion like earlier, so we're going to have side B over the side that's proportionate to it, which is this side right here between our right angle and our 30 degrees. And then we're going to set it equal to a proportion that we know both of, and that in this case would be 12 and 1. We are going to cross multiply and solve. Now to solve for side C, we know that side C is proportionate to the side labeled 2, so we'll set up our proportions again and solve. I want you to pause the video and try this second problem on your own, solving for side A and side C. Well, it looked like this problem got a little difficult with the square roots and the rationalizing, but we can make it through. Okay, so I drew my 30, 60, 90 triangle, and then I saw that my bottom sides here, I knew both of. Solving for A, I had to divide by a square root of 3. Some of you have a great calculator, and your calculator, if you type in it 3 square root 2 divided by square root of 3, it'll give you square root 6. So for some of you, all of this work I did, not necessary. But if you don't have that calculator, you really need to make sure that you're good at the rationalizing, multiplying the top and the bottom by square root of 3, since that was what was in the denominator, and then simplifying whenever we ended up having a 3 and a 3 on top and bottom. Solving for C, the same thing happened. I have to divide by a square root 3 here, rationalize it, and again I can simplify, in this case, the 6 and the 3, divided them both by 3, so I get 2 square root 6. This problem looks pretty fun. So we've got two triangles going on. We've got a 45, 45, 90, as well as a 30, 60, 90. I'm going to have to start by solving for my 45, 45, 90 triangle, because I don't know any parts of the 30, 60, 90. I don't know what any of my sides are. So let's focus in on our 45, 45, 90. It's always a great idea to copy down your special right triangle with your 1s and your square root 2. Let's solve for P first. So we're going to have P over 1 and 15 over 1. When we solve that, we just get P equals 15. Next, let's find R. So we have R over square root 2, 15 over 1, cross multiply, we get R equals 15 square root 2. Now that we've solved for R, we know one side of our 30, 60, 90 triangle. So now let's draw our 30, 60, 90 special right triangle and start by solving for T. So we'll start by setting up our proportion and cross multiplying and solving. Again, we're going to have to rationalize the denominator. And our 30 and our 3 simplifies further, so we get 10 square root 6. So setting up our proportion for Q, cross multiply, solve. Again, we're going to have some rationalizing to do here. And we get 5 square